I hope everyone can see my screen.
Yes, Surendra.
All right. So this is the course introduction where we talked about what we are going to do in this particular course. And today is the first session. And what we are going to do is mainly we are going to learn about how to use large language models to build the applications. Okay, so that's our main core aim basically. So we are hearing about that there is something called as large language models, and they also expose their APIs. So our aim is how we can use those APIs and how we can build applications using the power of large language models. And we will be using a framework called LangChain in order to achieve it. Okay. So today is the first module. So we talked about what is AI and what is machine learning. And we saw the definition of artificial intelligence, that the effort to automate the intellectual task normally performed by humans. So if you are building any application or any such system which basically mimic the human behavior or the way human perform a task, if you are able to create some applications which can also perform those tasks, right? So then we say that, okay, we have created one AI application. And then we talked about that this application is very broad, and it is broad because we have lot of things which are part of artificial intelligence. For example, this the biggest circle is basically the artificial intelligence, and all the things which are inside this AI circle are also part of the artificial intelligence. For example, machine learning, neural networks, deep learning, generative AI, LLMs, all these are called as artificial intelligence only. The way we achieve the artificial intelligence or the way we build the applications, the way we train our models, that basically differs a bit in all these fields. And we also talked about, if we talk about the rationale or the reason why we are training our models. For example, if we want to solve some natural language, problems, right? The language which we speak or the text language. If we are dealing with the problems which are involving this text or the videos or the language, then that field is basically called as natural language processing, NLP. Similarly, there is a field which is called as the computer vision, and that field basically deals with what? Deals with the images. Okay, whatever we do with our eyes, human beings do with the eyes. If you're building the systems which can see the images, they can analyze the images, and they can say whether the image is of a horse or a cat or a dog, right? Similarly, if you have uh, videos and things like that, then we call that field as computer vision. Okay, so this LLM has become very famous, especially in the field of natural language processing. Earlier, we used to solve these problems with the help of machine learning. Then we started using deep learning. And then these days, generative AI is the field where we basically make use of, we solve the natural language problems. Whenever we are using chat gpt and we are giving it a content saying that summarize or draft an email or extract the places out of this particular paragraph, entity recognition, question answering, translations, all these are examples of natural language processing problems. Okay, and then we have seen what is,
Surendra,
yeah.
on the let's say differentiation purpose, can
Hmm.
you go on the last slide? Yeah,
Hmm.
means on the differentiation between AI and ML, and that too, just think of a perspective from a, let's say there are questions and answer. So
Hmm.
how we can say means AI always kind of has ML into it, or ML can be let's say isolated to AI as well. They could be separate.
Hmm.
How
Yeah,
can we
see,
do that?
AI is this entire space. AI is basically a concept. It's not, a tool or some machine learning model which we can train. Getting AI is just a concept which says if you are building any application which can mimic like a human being, right? If, for
Yeah.
example, the human beings basically can see the things, can speak. If we have, some Google Assistant, or we have the Alexa, Siri, or we have the driverless cars, so all these are examples of AI machines basically, right?
ठीक.
So AI is, in a way, it's a concept, and these are basically techniques. For example, machine learning is a technique which by which we learn the pattern in the data. We create systems which can basically, learn from the data, and it can tell us. For example, if I want to calculate the price of a house, what I can do is I can feed lot of data of the prices of the house, and then my ML model will learn from that data, and then it will be able to predict the price of a house for the data which it has not seen in the past. Getting? We will do all these
Yeah, yeah.
things.
So
No
that
worries.
that learning process basically, that is means not straight away AI from definition perspective. That is part of ML.
Correct. ML. Yeah. Machine learning is basically we have a lot of algorithms, and we use those algorithms and we train our model, that is called machine learning.
Right.
And
And
neural network is also a machine learning. But the way it works is a bit different. It works not on the algorithms, but we make use of something called as the neural networks. We have neurons, which
yeah,
is
last
similar to
time
the
you explained.
correct. And deep learning is whenever the number of layers, we have input layer, we have output layers, and the layers in between those are called hidden layers. When the number of hidden layers basically increases from 8 or 10, then we start calling neural networks as deep learning, because they have very lot of neurons, lot of layers, and it's like deep thinking. They have more neurons. More neurons means more memory, more weights to store the information, right? And then when we talk about generative AI, they are, again, they are also the machine learning models. They are also, but and they also make use of the neurons. But the special thing is they are based on the transformer architecture, which we will see. Okay. And generative AI basically can generate images, audios, videos, and text as well. And within that generative AI, we have something called as LLM, large language models. So which basically generate text. But these days, or the LLMs which are being produced, or which are being released by these companies, they are capable of almost, they can also create images, and they can create the videos as well. Okay. So we
Yeah.
have seen what is artificial intelligence. It is a software that imitates human capabilities, right? Humans are able to see, they are able to hear, they are able to speak, all those capabilities. Now, when we try to bring into some system or some application, then we say this is an AI machine, predicting outcomes and recognizing patterns based on historic data, right? So this is something which is being followed by machine learning, neural networks, or even your LLMs. They learn, all these systems learn from the data basically, recognizing abnormal events and making decisions, right? So all these are basically examples of the AI interpreting visual inputs, extracting informations from sources to gain knowledge, understanding language, and engaging in conversations, right? Okay. Now we'll talk about the history of AI basically. So AI is something not which is being introduced very recently, but yes, generative AI and the large language models, we see this boom maybe from the last 5 6 years. Okay, but AI is not something which is very new. This is very old, and it is there in the world since 1950s. But the paradigm, or the way we used to think about artificial intelligence 50 years back, was different than how we do it today. For example, initially the AI was mainly called as rule based AI. And the thought process was that what we can do is we can create so many rules, right? And if we keep on adding or creating new rules, like, some if and else type of conditions, and if we code all the rules, then at some point of time, we will be able to create so many rules and so many logics that one day we should be able to create an application which will be equivalent to a human brain or a human being. And that those many rules will be able to take decisions just like human beings, or they can able to do the task just like human beings. Okay, so that was a thought process. For example, if we need, let's say we have a housing price problem where we need to calculate the price of a house. And let's say the price of the house depends on the number of rooms, square footage, and location. Okay, so these are numerical values, but location is not. So let's say this is a location score. 0 means the worst location, 10 means the good location. Okay, so if you have these three are basically called as features. So these, the number of bedrooms, square footage, and location are called as the features, or you can also call them dependent variables. And price is your, sorry, these are independent variables, and price is your dependent variables. The value of the price depend on these features. Okay, so in symbolic AI or the rule-based AI, what we used to do is we used to create such rules that price is equal to W1 into number of rooms. These are weights basically, W1, W2, W3. And our task was that earlier, if we have the data of, let's say 100 houses, we used to solve those equations and we would find the values of W1, W2, and W3, the weight of, or the, I mean, just like we used to solve the equations, the equations in 10th class, right? X plus Y is equal to something, 2x plus 3y is equal to something. Then we used to calculate the values. Just like that, we were manually calculating the values of weights, which would satisfy these equations. And then if you have a new data like if you have the number of houses, square footage, and location, we were able to calculate the price of the house. I hope this is clear, guys. So what we were doing is basically we were creating the rules and we were feeding the data in the classical programming, right? What we do, even if you talk about any piece of Java code which we used to write, we define the rules. We say if there is a method which take input parameters and x and y, we used to say okay, z is equal to something times x plus something times y. So we define some rules and then we pass some data and we used to get the answers. So what are our rules? Rules are our like W1, W2, W3. What is our data? Data is like number of bedrooms, square footage, and location. And what our system will do, it will give us the answer. It will give us the price of the house. But these days, what we are doing is we make use of the machine learning models. So how they are different? They are different in the way that we basically pass only the data. Data is like number of bedrooms, square footage, and location of various houses. And we also tell the system, the machine learning algorithm, what are the prices of those houses basically. Getting, we will say P1 is the price for this house, P2 is the price for the 3 BHK, 100 square feet, and location is score is equal to 4. So such data we feed to the system and we feed both, right? The input or the features as well as the dependent variable, the target variable, and we leave it to the machine learning algorithm to learn from the data how they are related to each other, and then it will create certain rules. Those rules it will use for the future prediction. Are you getting, guys, the difference between these two ways?
Yes.
Hmm. And then if we talk about common AI workloads, we have, like as I said, computer vision is the area where we in the AI we try to interpret visually through the cameras, videos, and images. We try to analyze those things by vision. NLP deals with the language problems. Machine learning basically deals with the data and the stats. The predictive models, all the predictive models, document intelligence, knowledge mining, generative AI. So these are the different, branches or fields you can say within the AI. Then we talked about what is machine learning. Machine learning is creating predictive models. Okay, for example, as I said, X1, X2, X3, they are my features. They are also called independent variables. Y is my label. This is my price of my house, let's say. P1 equal to P1 is the price for these variables, these features. P2 is the price for these variables. So when we pass this data to our algorithm, there are a lot of machine learning algorithms, like we have logistic regressions, we have decision tree, we have random forest, we have XGBoost, naive Bayes, logistic regression, all those algorithms we have. And depending on our problem, we choose the algorithm and we feed the data, training data. And then once that it is being trained, our model is ready. Once our model is trained, what we can do is now we can give some value of x2, x3, or x2 and x3, which my model has never seen, right? And then I will get the prediction. I will get the price of my house for that data, for that unlabeled data. Okay, so this data I am using only for the training. Any questions?
Label is basically answer or
Answer,
output
correct.
from that equation, the
Hmm.
second last slide.
Correct. These are the prices. See, my system will only be able to learn the pattern if we give the features of the house and also the price of the house. Then it will understand, okay, all the 1 BHKs are having low price. All the houses where the square footage is less, those are having the less price. And all the location scores which are more, which are at a good locality in the proximity of hospitals, schools, those are having high prices. So it will basically calculate whether it's a directly proportional or it's inversely proportional. And then it will be able to create some equation or some curve which will satisfy all of these. It will
So
not
in a
satisfy.
way, internally also it will create weights.
Yes, yes. Internally, it will create the weights and it will be creating some curve, right? Which can satisfy these equations. It cannot satisfy all of these, right? 100%. How can a curve can satisfy a lot of points on the space all at a time? If you do that, what will happen? It will become what you call overfit, basically. So these are machine learning concepts. I think uh, it's sometimes difficult to explain because they in themselves are subjects, right? They take a lot of time. Anyway, I think you got the idea, right? And we will train one model also. Okay, we will do some hands-on so that you will get better intuition. Okay, we talked about the type of machine learnings. They can be supervised or they can be unsupervised. In supervised, we have the data which is already labeled. We know the price of the house. In case of unsupervised machine learning, we just have unlabeled data. For example, images of different flowers. And then we leave it to our algorithm to find how many species or how many varieties of flower are there in these images. Okay, so then what my output will be, it will create 3 different clusters. Okay, whatever images you have fed to the system, it has, based on their features, their length, their width, their color, it is able to find there are majorly 3 different species of the flower. Okay, and then if we pass some flower which was not, some image of the flower which was not part of my training data, then it will be able to tell me whether that image belongs to the class 1 of flowers or class 2 or class 3 class of the flower. Okay, so this is called unsupervised. We don't know upfront what is the name of the class or what variety or the species of this flower is. We let it machine learning algorithms to decide. Okay, but in case of supervised, we have the label data. And in again, there can be 2 type of problems. One is the regression problem, other is the classification. In regression, just like housing problem, your output is the numeric value, or all your labels are basically numeric values. It can take any value. The price of the house can be 1 lakh or 10 lakh or 1 crore, right? Or any number in between it. It's a continuous function basically. Whereas in case of classification, my output is just like, it can be just 2 classes, whether a patient is suffering from cancer or not. My email is spam or not. Or maybe if we have lot of classes, then maybe the penguin is a class 1 penguin, class 2 penguin, or class 3. Got it? So that's the basic on machine learning, type of machine learning. And then just to give you more intuition about, so let's say we have the data where we have the two-wheelers, cycles, scooters, and we have four-wheelers like vans or cars or things like that. And if I pass these images, if I cluster them like that, all the cycles in one group, all the four-wheelers or all the cars in one, and all the vans or trucks into one category. What I have been doing, these are bikes. So when I say these are bikes, what I am doing, I am labeling my data. Correct? If with each image I say this is a bike, this is a bike, this is a bike, and this is a bike, what I'm doing, I have labeled my data, isn't it? I label all my car images also. I label all my truck images also. So this is called unsupervised learning. I think I explained it in a different way, but let me explain you again. So this is my problem, right? This is my unsupervised problem where upfront I don't know what these images are or how many categories are there in this cluster of images. Okay. So when I feed it to my machine learning algorithm, unsupervised algorithm, what will happen? It will be able to segregate similar things into one group. So all the images which are having two wheels, it will create one group. All the images which are having four wheels, or maybe, the size is small. So features means it will be able to see it has a handle, it has a paddle, or, it has two tires or things like that. So based on the features of each image, it will calculate whether this image is similar to this image or not. If they are similar, it will club into one group. It will put those images into one class. Similarly, for all those images where the features are similar to each other, it will place them into another group, and this as a third group. So what I am doing, I'm saying in the end, I am able to find the images of bikes, the images of cars, and images of trucks. So this is called unsupervised learning. किसी को कुछ क्वेश्चन है तो feel free to ask, guys. If you are hearing all these things first time, then maybe you have some trouble understanding. Is it clear,
Yeah,
everyone?
yeah, I think it's coming out okay to me at least.
Okay, great. This is second type of problem where I upfront says this is my bike, this is my truck, this is image of truck, this is image of car, bike. So I feed this data. Along with the image, I also tell my system the target variable or the dependent variable, which is like label data, bike. This is a bike. This image is a truck. Okay. So both my dependent and independent variables are fed to the system in one go. This is supervised learning. Now, what will happen if I have image, okay, which my system has not seen or which was not part of this data? Now it should be able to tell me whether it's a car or it's a truck or a cycle, isn't it? So this is called supervised learning, where I'm feeding my system with the label data. Got it? All right. So there is something called model training and evaluation. So this we just discussed, but when we do the training, what we usually do is we create two parts of my data, maybe 70-30 split or sometime 80-20 split. Okay, so this is my label data. I already know the output. The price of my houses I already know, but still I will just create two parts of my data. One will be used for training and other will be used for validation. Can anyone tell me why did I put this aside for validation? Why not some other data?
We need to evaluate whether the model is working as expected. So I should know my expectation before I
Correct.
do it.
Correct. In order to validate my model, which is being produced after training with this data, I should have some data for which I know the actual price of the house, right? Then only I will be able to compare the predicted price with the actual price, getting whether my trained model is able to predict or not. So I need some data, some label data. for my validation as well, some actual data, right? So this is the idea. I have an algorithm, I train my model, the model will create some function like this, some equation, and then once I put x1, x2, or pass these values, it will predict something, some y dash. Then I will compare how y y dash is, how much y dash is closer to my y. If it is far away, that means my accuracy is less. If it is close enough, that means my accuracy is good enough. Okay, so that's how I evaluate my models. With some part of the data I will keep aside and will use for the validation.
Hey, one question.
Mhm,
So, as you see Google Photos, right? So we upload a
mhm,
lot of photos.
mhm.
Then it kind of clusters them together.
Exactly. Mhm.
Then it asks for a label, like put a label name
Right, right.
of that group. So is that unsupervised learning?
Unsupervised learning.
Okay, so that is unsupervised learning.
Mhm.
But in a way, it's asking me to put the label.
Right. So very good question. So the thing is, in case of unsupervised learning, it can tell you the different classes, how it can tell you this is a bike or something. It's just clustering those images together because they are similar to each other. So in
Mm.
Google Photos, whatever photos it will find of myself, it will create. Okay, so this is these 100 photos are of person XYZ. But
Mm-hmm.
you need to label it, right? Okay, this is Surendra, or this is Akash, or this is Deepak. Isn't
Mm.
it? So that next time when you come back to the Google Photos, you will simply say, I want to filter all the photos of Surendra. So it just for the system, it's just class 1, class 2, and class 3. If
Right.
we label it, then it's good for us, right?
Okay, okay.
Then we
Okay.
know basically, okay, these are the photos of bikes.
Got it. Okay, okay.
Yeah.
Nice.
Similarly, in case of deep learning, these systems are also machine learning models, but they are inspired from, but the way of training the model is a bit different. It's more like inspired from human brain, though it's not close enough to the brain, how it works. But since we also have neurons which are being triggered, when the one neuron is triggered, it basically sends signals to the some other neurons. And if those signals are strong enough, they will activate they will send signal to the next layer and things like that. Okay. The similar concept was taken and then they created something called as the neural networks. So this is an example. This is our input layer. This is our output layer. And these are hidden layers. These are called as hidden layers. Okay, so they can be like 2 layers, 2 hidden layers, or maybe 10 hidden layers. That depend on the complexity of our problem. If we increase the layers, its trainings become very difficult. It need very good resources, good infrastructure in order to train, because we will have so many weights to calculate, and so many weights to change and things like that. Okay, so for simpler problems, we keep our number of neurons and number of layers to minimal. For example, this is a problem where I need to find the species of the penguin. So just a second. So what I will do is, these are the features. This is X1. So I am basically measuring the various features, hands or the limbs or height maybe. Okay. So for the first penguin, it's like X1, X2, and X3 and X4. These are the values. These are the different features we talked about, right? We pass those features to the input layer X1, X2, X3. Then this basically has some activation function. All these layers have different neurons. So this is one neuron, this is other neuron, this is third neuron. And each neuron is basically connected to all the neurons of the next layer, like that. This one will also be connected to the all the other layers. So you can see the number of connections. And all these connections have basically weight. This is like weight W1. This is like weight W11. Let's say this is called first layer and this is second layer. So from first to second, this is called W11 weight. This is called W1 from first to 2, W12, W13, W14. Like that, we have lot of weights. Okay. And when we train our model, what we are basically doing is we are calculating the optimum value of those weights, okay, for which my error will be less. Is it making sense? So my eventual aim is to calculate some optimum values of weights which will satisfy most of my training data. See, I cannot have some points which will satisfy all the input variables, right? There will always be some error. So I want to achieve a point where my error is minimum. My target is to make the error minimum. Okay, I need to find those weights for which most of my training data fits well and the error or the deviation is the minimum. So in this case, I pass lot of data of these penguins, and then the output, I get the some score, some probability score. It will say that, okay, this image after training, if I pass another image, it will say for this image, the probability of being it the first class or the class number 0 is 0.2. The probability of this penguin image to be belonging to the class 1 is 0.7 and the third is 0.1. Then we will say, okay, this is the maximum probability. This image basically belongs to my first class. Same problem we can also solve using machine learning model, but we use deep learning models for complicated problems where the number of features is very large. For example, if I talk about a 500 into 500 pixel image, so what will happen? Each pixel basically is one feature or one attribute. So how many attributes I have now for an image? 500 into 500, that will come 25 into 10 to the power 4. These many features, these many x1, x2, x3, x4, up to 25 into 10 to the power 4. These many features. With these many features, my machine learning, my traditional machine learning models will not work basically. So what I do is I usually, for images problems, for video problems, for language problems, I usually use neural networks because they have so many weights. It can understand the difficult patterns. It can store those values more efficiently. Okay. I know you may not be grasping 100%, but this is just to give you some
But
gist or some intuition. Yeah, tell me.
but fundamentally, see, in machine learning, you're using some algorithm, right? And
Mm-hmm.
deep learning, also you are going to use the algorithm.
Correct.
Are we saying so? What is different then, right? So you're passing parameters. In this case, you're passing a lot of parameter.
Exactly.
In learning, you're passing less number of parameter. So
Yes.
are the algorithms completely different? The hardware will be totally different, right? You will have because you're processing, you need so much processing, so you definitely need a lot of GPUs.
Exactly.
Machine learning probably can run on CPU, but are the algorithms same or
So the
it's
so
yeah.
the way they work actually differs basically.
Okay.
Okay, so they have some different way to reach to the optimum values, and machine learning problems have some different way. Okay,
Okay.
the
Okay.
way in which the error or the deviation is calculated is quite different, right?
Okay. Okay. So help me understand this one more time. So in
Mm-hmm.
this case, what you did on left side, you passed all these four parameters:
Mm-hmm.
fin size, beak size, height of this bird, or whatever
Correct.
this image is, right?
Mm-hmm.
And then you passed this, and something happened in this algorithm, and ultimately you came out with a point 0.7 score that it this matches the image number 1, not the image number 0.
These are classes basically, three species of penguins, you can say.
Okay.
Mm.
Okay.
So what happened earlier is, let's say I have, 1 million images of penguins. So I label those images whether they belong to class 0, class 1, or class 2.
Okay.
Okay. Then I trained my model. Now
Okay.
my model has learned all the images which were labeled 0. They
Hmm.
have some different features. Maybe
Got
their hands are small or their height is less, something
it.
like that. So they
Hmm.
have understood that pattern, that
Hmm.
okay, all the images with the class 0 has these things in the common.
Got it.
Whereas all the images which were labeled 1, they had some different features. They had long beak or something like that, or colored beak maybe. So they have stored that information in these weights. And
Got it.
similarly for this class 2, they have stored some peculiar features and they have stored that information in the weights. Now, if I pass some image which it has not seen in the past, then it will do same thing, right? It will calculate its features, and then it will try to compare these features with the stored features, whether its features are close to the class 0, class 1, or class 2. So it has seen that 20% of the features are matching with the 0, 70% features are matching with the class 1 penguin, and just 10% with the class 2. So this final decision is, okay, this image belongs to the class 1 penguin species.
Got it. Okay,
Okay.
that's very helpful. So that's how the facial recognition works, right? When
Exactly.
somebody at the airport
Yeah.
kind of like tries to, okay, got it.
So there is something called as CNN, convolutional neural network. So
Okay.
even for the specific areas, for for working with the language, there will be some different kind of neural networks. In order to deal with the vision problems, there are different. So when we talk about vision problems, we actually use some specific neural networks. They are called convolutional neural network, CNN.
Mm.
Okay. And there is something called RNN, recurrent neural network, which is used to deal with the NLP problems.
Got it. Okay.
It's not one model. I mean, not one architecture fits for all the
Right.
problems. So that's why we have a lot of variations.
Nice. Okay. Very good.
Okay. So I will just iterate whenever I am training a model. My aim is basically to find the right weights, finding the right values for these weights. Okay, this is, for example, this is for neural network. This is my input layer, this is my output, this is my hidden layers, layer 1, layer 2. So whenever the data comes, some manipulation or some calculation happens. Okay, so with the function which you see inside the neurons is basically called activation function. So whenever you pass something x1, what it will do is it will do some operation on that data and it will calculate some value. Okay. So that operation basically, that means whenever I pass my data, they undergo some transformation. So let's say y equal to x square. So when that operation happens, the new value is passed to the neuron again. Then some operation will happen here. Some operation will happen here, like that. It happens. Okay, so my aim is when the data is passed, some data transformation happens because of those activation functions, and some operations will held in the second layer, and finally some predictions will be produced. So my aim is to find those weights for which, let me go to the next diagram. So this is layer 1, this is layer 2, this is my prediction. These are weights on the layer 1, these are the weights on the layer 2. So when I predict the values y dash, there is something called as a loss function. I basically calculate how far are my predictions, because I also have the true values or the actual values. Let's say for the image 1, the penguin belongs to the class 0. So this I already know that my first image belongs to the class 0. But when I start my neural network training, what it will do is my weights are randomly initialized. They are given some value randomly by my code. Getting? W1 may be 0.1, W2 may be 0.3, W3, they are randomly initialized. These weights get randomly initialized at the very first time because my system is not trained. So now what happens when I pass my first set of data or the first row record, it will say, okay, as per my weights, this belongs to the class 1. This penguin belongs to the class 1, but in actual, it belongs to the class 0. Yes or no? Because this is supervised training, guys. So I already know the answer that this belongs to the class 0, but since my model is not trained, it will give me some absurd answer at the very first time. It will say this is class 1. Then what I will do, I will calculate the difference. I will create a loss function. I will say my predictions are far away from my true targets. So that function will define the amount of error, and that will be a score. And there will be an optimizer which will change those weights in such a way that when I get my next record, this loss score should reduce after every epoch. After every iteration, I change my weights in such a way that this difference between the true and the predictions should basically reduce. After some training or after some point of time, what will happen? The weights will be changed in such a way that when I pass my image, it will be able to correctly predict, okay, this is class 2, And in actual also, it's a class 2. That means my model has been trained enough. The weight are now optimized. Their values align in a way that it is able to predict the images correctly. At that point of time, my loss score will be very less. And then I stop my training and I will say my model is trained enough. समझ में आया guys?
So, Surendra, this is relevant for supervised learning, right? For if you want to train a model which
Correct.
falls under the category of supervised learning.
Correct.
So, for large language models,
Hmm.
those are mainly unsupervised models,
Yeah,
right?
I mean, we will cover that
Okay.
in some time.
Okay.
Okay, so just give me some time. We have a slide for that.
Sure.
Okay, so these LLMs are basically supervised as well as unsupervised. Both kind of trainings are there. Okay, so but you are able to understand this concept, right? How these machine learning models or neural networks works. They calculate the randomly initialize some weights, but
है
those weights are random.
एक आधा
So
है तो क्या करूंगा हाँ आधा कर दो उसका कम ही खा जाता है ये परवल
yeah, can you mute yourself? I think. All right, so let's do some hands-on.
When we will do the hands-on, can you go back to the same picture that you explained and then help us recap?
Yeah, sure.
All right.
So what I will do, I will create another folder. Okay, so my first step is to create virtual environments. So I will do it quickly, but I will in some session, maybe second or third, I will tell you what is virtual environment. So right now, I have activated my virtual environment. And So I'm just installing all the required libraries. So meanwhile, let me show you the data. So this is my data for my housing problem. So you may be wondering what these headers are, but since this is a very famous problem, let me go to so I was talking about the data set, right? Which we use to train our model. So let's say this is our data set. This is boston.csv file. And all these columns which you see, they are basically my, so this one is my dependent variable and rest are independent variables. Okay. So for my housing problem, for example, town, this is the name of the town where this house is present. There is a field called tract, longitude, latitude of that area. MEDV is basically the price of the house. CRIM, per capita crime rate of that particular town. ZN is the percentage of residential land. Indus. So they are different features of my problem. Okay. So just like we took in the slide, right? The square footage, the number of rooms plus the location score. So instead of those three, we are having these many features or these many parameters which can influence the price of my house. Okay. So now I want to feed this data to my machine learning model so that it can learn from the data. Okay. And it can start doing the prediction. Okay, so these are meaning of those different headers. What is the age, percentage of the owner occupied units built? Okay. So this is done. I think I need to install a couple more. Install scikit. So these are different Python libraries which I'm using in my code. So I need to install them into my virtual environment. Okay. Scikit-learn is the library which is having all the algorithms, right? It has algorithms like logistic regression, linear regression, whatever algorithm you want to use, they are already coded and present in this library. You just need to choose that library or that algorithm and you need to fit your data. Okay, so there will be a lot of things which you may not understand. And since this is not a machine learning course, uh, but in order to help you out, I am just giving you a very high level overview. So this is my data. All right. I think there is Seaborn. Seaborn is used to visualize your data, to create those visualizations, your graphs. All right. So I think I have installed all the libraries. Now this is my code. This is interactive Python notebook. Okay. So this is a Python notebook. This is not .py file. This is py notebook file. The specialty of this py notebook file is you can basically run it cell by cell. It's asking me which environment you want to choose. I will choose this one in which I have installed all my required libraries. A lot of things are required when you are doing it for the first time.
Surendra, which tool is this? Visual?
This is VS Code,
Yes. Okay.
Microsoft VS Code.
So
Okay.
for Pi, we can use this PyCharm also, right?
Yeah, I mean, I will be using this VS Code for my entire course, and this is, a very standard product being used in the industry as well. So I would recommend using this one. But
Okay.
yes, as long as Python is required, you can use any IDE. But
Okay.
I will be using this. So
Okay.
they have basically a lot of plugins, right? Which will help you if you want to integrate it with Azure, if you want to.
Okay, in this tool. Okay.
Yeah. All right. I think almost done. This is running my first cell.
So in VS Code we can do means Python programming also.
Yeah.
Okay, I can see it's available in my company's software. Yeah.
So I have executed my import statements. IPY-NB file is very useful if you want to debug your code, if you want to run it one by one, right? Otherwise, if you have the .py file, you just need to run it once, and then if it fails in the middle, then you need to fix that, and then you need to rerun it. So it's just not easy to debug. So that's why IPY-NB is very useful in debugging and running your program cell by cell, and then it's also super easy to share the code in this format. Okay, you can also add comments and things like that. Okay, so all right, now I will load my data, which is boston.csv file. This is a data frame. In the Python, there is something called as data frame, which will help us to load our tabular data. This is pandas pd.read csv and the name of the file. Okay, so if you do data frame dot head, what you will see is you will see the top 5 rows. You can see the top 5 rows. Whatever data I had in my CSV, now it's being there in the data frame object. These are the different columns. Okay. And then if I need to draw some plot, I will use Seaborn SNS. Okay, I have imported Seaborn as SNS. So I do SNS dot relational plot, I think rel means, and then I have defined what is my x, what is my y, what is my size and hue. There are different parameters. So this is just to show you these Python libraries are very rich, and you can analyze your data by drawing it through different plots. So this I just created this plot. If I see the shape, this is a command to see the size of your data which is loaded in the data frame. There are 506 rows and 16 columns. Okay. So what I want to do is I have created two different objects, X and Y. And in the X, I want to drop couple of columns and keep rest of them in my X. This will be a set of my independent variables. Okay, so I have dropped medv because medv is going to be part of my target variable, right? I want to calculate the price of my house, isn't it? So this is my label data. So all my labels have been put in Y. Getting? So what I'm doing is I'm creating this thing, X and Y. So in my Y, all the values of house prices are there. Okay. So from the data frame, which was having both dependent and independent variables, I have segregated my target variable, which is price of the house, in my Y variable. In the X variable, I need to remove this one for sure because it has moved into the Y, and these two are basically not useful. Okay. So I have dropped them. They don't have any, good relation or with the price of the house. So we have dropped these columns as well. So this you will be able to find out by doing some data exploration, by plotting some graphs, and then you will conclude. So this is my X and this is my Y.
What is
And
the meaning of this axis one?
X and Y.
Axis is equal to what?
Axis means basically whenever I am removing this data, right, I have to give axis is 0 or 1. That means from these are basically name of my columns, town, right, and track. So I'm instructing the data frame to drop these columns basically. So axis is 1. If axis is something like horizontal, then it will delete some particular rows basically. Here I am dropping the column itself. Okay, so don't go into that much of details, right? Because this is not, the aim is not to teach you how to train the models, but it's just to give you some idea what is training. Otherwise, you kept on wondering how the models are trained, how difficult it is. So this is just to show you how easy it is to train the models. But you are not supposed to do all these things. We have some different target. We have target to create applications using LLMs. All right, so I have the values in X and Y. I will just, there is something called scikit-learn model selection. I'm splitting my data into two parts in the ratio of my test data will be of 0.2 size. Okay. Where is that? This one is my 20% of the total data. This is what I'm defining here. Then if I want to use the linear regression algorithm, I have to do scikit-learn linear model import linear regression. This is the object. Then what I do, I fit my data. Okay, fitting means training the data. So this is my algorithm. In this algorithm, I'm passing my X and Y. Okay, my label data I'm passing. I'm passing the features of my house, and I'm also passing what are their prices. Okay, so that my model will get trained and it will learn from the data. So once it's been done, so this is being done. This is my LR model. Now, if I pass, I kept that 20% of the data, right? So if I pass that X test, it should be able to tell me the values of Y. So these are values of the Y. These are prices of all the houses which are there in the 20% of my validation set, test set. So these are the prices. They come in the form of an array. Okay. Now what I will do is I will compare these values with what, guys? Can anyone tell me? These are my predictions from my model after training.
With the actual labels.
Exactly. Okay. So that will help me to find the accuracy of my model. So since this is a regression model, right? My label is a continuous variable. It can give me any price. So this model is a regression model. So in order to find the accuracy of my regression models, I have some matrices like RMSE or R square, root mean square error, or sometimes I have MAE. There are a couple of matrices in order to find out the accuracy of my model. So when I do that, when I run that, I will see my root mean square error is 40 or my R square value is 64. Okay. If I check accuracy, my accuracy on my training data is 67%. On my test data, it is 64%. That means 64% is my actual accuracy. I will emphasize more on the test data, right? So test data accuracy on my test data is 64%. So 64% of the time it is able to tell me the price of the house. Does that make sense? ऊपर से तो नहीं निकल गया सब कुछ?
थोड़ा सा
थोड़ा सा निकला?
हाँ निकला
That should be fine basically.
हम्म
है ना?
so basically what you did is you wrote a Python notebook है ना
हाँ.
and then all the data that you passed, see training means you're passing a data could be a lot of data.
Exactly.
Data आपने कहाँ pass किया exactly? You passed it as a CSV as an input.
Yeah, I read the file, CSV file, and I
Hmm.
loaded that data into a data frame. This is a Python object. And within that data frame, then again I segregated into X and Y. Some columns from that data frame, I put in my independent variables and the one as the dependent variable.
Okay.
Okay. So that X and Y set, then I pass to my model. I'm saying fit X and Y. So it understand, okay, this is my input variables and this is my output. So it does the training basically. That model got trained. But
So what model are you using exactly?
This
What
is linear regression model.
Linear regression model.
Yeah,
Okay, that is the name of the model.
Yeah.
Okay. So it must be some simple raw model like there are
Correct. So
some
linear
models.
regression is a model basically which try to fit a straight line in your data.
Got it. Okay. So then you put all this data in this linear regression model, and then you ran to basically train it.
Correct.
Huh? But now the question is, how did he know what are the errors and what is the accuracy? How would he know, right? Because you're putting wrong data, incorrect data. But what does this guy know, the accuracy or the mean or the error?
So that so it knows because we splitted our data into two parts, right?
Okay.
For these houses, we actually know the prices. But for this set of data, we are just passing X1, X2, X3. We are not passing the label.
Right. Okay.
We are asking the model for this data X1, X2, X3, tell me the price of the house. So it will give some predictions. Now those predictions I will compare with the actual values to see how different or how deviated they are. That basically will help us to calculate the error, the loss or the accuracy basically.
Got it. Okay. So on basis of the right data, data, it is determining how good it is performing.
Exactly.
Okay. ठीक है इतना काफी है समझने के लिए.
Similarly, just like this linear regression, we have lot more algorithms like decision trees. You have like, they create some tree kind of formation. They are basically different ways to train your model, right? In this model, you will see the accuracy is 58%. So it has increased from 54 to 58. If you go to some other models like random forest, the accuracy may be further increased. Now my model is giving 75% accuracy, right? So like that, you basically, then this is something called as a feature importance. So once I have trained, what I can also do is I can find out by this line of codes, which feature is basically affecting my house price the most. So RM is the feature which is affecting the price of my house the most. Next is NOx. NOx is basically NO2, NO3 or pollution basically. Okay, so the pollution also help us to affect the price of the houses. If the pollution is high, the houses near that area is less basically. Okay, so this is also you can do. There is XGBoost. So there are a lot of algorithms and they keep on increasing the final accuracy. This is having some 78% accuracy. Okay. You should not try. You may get a lot of errors and you will wonder. Okay. But if you want to try, you can just try this linear regression. Okay. That will give you some intuition on how the models are trained. Okay. Similarly, I have this was a problem of classification, isn't it?
So Surendra, one question. So training accuracy, if you have to improve, so you showed that with different models, the training accuracy is different, right?
There are two
So
type of accuracies. One is the training accuracy, other is your test accuracy.
just
We should not
accuracy.
be bothered more about the training accuracy. If I
Mhm.
increase the training accuracy, if it is increasing, that means my curve is getting overfit. Okay.
Mhm.
Okay, overfit. That means my model is basically by hurting my data, my training data.
Mhm.
So what I'm trying to say is, if this is, oh my God, I use this very rare, I think because I zoomed it, it has become so dark. Anyways, let's say this is your y-axis, this is your x-axis. If these are my points, right? Let's say this is your input feature and this is your price. If price of one house is like this, okay, like this, other price is like this, other price is like this. So this is just 2-dimension. Now just think if you have 10 features, it will be 10-dimensional, right? So what my aim is, after the linear regression, what it will do is it will create one straight line. For which the errors, so what is the error for this first point? This much is the error, right? For the second point, this much is the error, this much. For this point, this is the error. So what my aim is to create this line or find out this line, which basically can produce the least error. Okay. If my output is like that, what will happen? This is huge error, this is huge error, this is huge error, isn't it? So what I do is I try to find out that optimum line for which most of my points satisfy and the error is minimum. Okay. Does that help? Yes, no?
Yeah, so if you have to improve the test accuracy, right?
Hmm.
Do we have to
Okay. Okay.
try with
So
different models, or is there
yes,
a way to
yes,
improve the
you
accuracy?
have to try the different models. So
Okay,
they work differently actually,
okay.
right?
Because
So
earlier when you mentioned you
hmm,
talked about loss function and loss score and how we can optimize, etc. Can we do that with the same model, or we have to try different models first?
just give me a second. I will just cover the first part of the question. When I was saying the training accuracy, right? So what I can do is I can have some algorithm which run like this. Let's say, oh, this is not curve. Okay. So that will create some model like, which is like moving something like this. It is going from point to point. Are you getting? If my model create such an output, which basically satisfy all the points, in that case, my error is although less and my accuracy is 100% for the training data. But this is not the ideal situation, right? My curve should be something like this one. Okay. चलो कोई बात नहीं आपको नहीं समझ में आया तो that's fine but I think this is sufficient. What was your last question?
So
Someone was asking. Yeah.
yeah. So you mentioned about loss function and loss
Mm-hmm.
score.
Mm-hmm.
After a first prediction, if
Right.
the output is way off, then
Mm-hmm.
we try to use loss function, loss score, right?
Correct.
So do you use that as part of training a model?
Yes, yes. So that is being used. So in this case of machine learning models, once you train your model, you get some output. Now there
Hmm.
is no further way to improve it for a given algorithm. You have to switch to some different algorithms. But that loss function was actually for the neural networks.
Okay,
In case
okay.
of neural networks, your loss function is calculated, and in order to minimize, it will go back and change the weights and it will move on until it reaches a point where your loss function is minimum. And
Okay.
then there we have to stop the training. Okay. So let me take another problem, which is like a classification problem, which is like whether the email is spam or not. So if I click on the input data, or maybe let me open the CSV file. Sometimes I feel I should not take this machine learning and all, otherwise it basically confuses everyone. But then I feel let's take it, it will help somehow. So for this data, this is a classification problem. Classification means my answer is either yes or no. It can be binary or a multi-class. Okay. For this category, I have just two columns. Okay. One is my target variable, which says whether a given email is a spam or not. Spam is a spam when a not spam is also called as ham. Whether the email is a ham or spam. Okay. So just like in our Gmail, right? We see some spam emails get directly shifted to my spam folder. So how that basically works? That works on this algorithm only. So it will see whenever we are training our model, first we have to give it some data so that it will understand what kind of emails are basically spam and what are not spam. So if you see, for example, in the spam, you see free entry into a weekly comp to win FA something, some free tickets, or some spam email is there. Free message here, hey darling, it's been 3 weeks now, no word back, blah blah blah. So you can see clearly the spam emails have, this is a winner. As a value network customer, you have been selected to receive £900 prize or something like that. Right? So all these are spam emails. And some are genuine emails. Even my brother is not like to speak with me, something like that. So if you feed this data to my machine learning model, it will be able to understand, okay, for the spam, I'm seeing there is something called free is there. Sometime it's a lottery, or some dollar value is there, or maybe some link is there. Click on this link. So what the algorithm does is it learns from this data, and it will come to know, okay, for all those emails where these words are coming, they are probably the spam emails. Okay. This is movie club, something like that. So what we will do is we will again train our model with this data so that it will learn from it. This is spam. Now we will use naive Bayes theorem. This is another algorithm. Now I'm reading my data. This is head of my data. Okay. Don't worry if you don't understand everything. Now I will again splitting my data, test train, and then I am using count vectorizer, and I'm fitting my data x dot train values. Okay. This is my model, which I'm going to use. Again, I'm doing model dot fit training data, and my train output, my model has got trained. Okay. And then now if I give it this problem, right? If I give it these two emails, the content of these two emails, it should be able to tell me whether which one is spam or which one is not spam. We are just testing it. So if I do that, I will see it is able to say that the first email is 0. That means it's not an spam, it's a ham. Hey Mohan, can we get together to watch football game tomorrow? Right, so it is saying it is, let's say if I change it to something else, you won the World Cup ticket. Okay, that's it. So if I change it like that, you can see it has turned to 1. Right, so now my model is saying this email is basically a spam, just like the other one, up to 20% discount. Getting points? Because my model has been trained, now if there is any incoming email, it will be able to tell me whether that email is a spam or not, because I have trained it. It has learned from the data. Does that make sense? Its accuracy is 98%. Okay. So that was just to tell you a classification problem. Similarly, we can have some neural networks as well. I have not tried this for a long, but let me at least show you this code. In case of neural networks, what we do, we use some libraries called TensorFlow, some NumPys, and then I create the model, right? It's a dense neural networks, number of units, input shape is one, some optimizers I need to use, my learning rate. I think it will be too much for you guys to understand this. And then I train my model. This epoch is basically the number of cycles I want it to run. 500 epoch means it has gone through the data once, it has found some error. Now it will change the weights. It will again send the data again to find the error. It should be have decreased and things like that. Okay. Can we, yeah,
Is it the layers that Epoch is?
your voice is too low. Come again, please.
So the Epoch you mentioned, right?
Epoch, yeah.
Yeah, Epoch. So those are the layers that we give?
No, the layers are basically TensorFlow.keras.sequential layers.dense units 1. So this is, I think, the number of layers. Okay, unit 1. That means it is having just one layer. If I change it to 3, the number of layers will become 3. And this is my input shape, means my input data is like just one data, just x1. If I have x1 x2 x3, then I will make it 3. Okay, so likewise I can code my neural network basically. But in case of my other ML algorithms, they are pre-built. Okay, I was just passing my data and then getting it trained. Here you can add as many layers. You can also change your how you want to calculate the loss. And there are a couple of optimizers. You can choose some optimizers. Okay, there is something called the learning rate that you can define 0.25 or maybe 0.02. There are a lot of things actually. There are epochs, means the number of cycles. So this is first epoch, and then my loss was 80%. In my second epoch, my loss got further increased, then got further increased. So my loss is increasing. Okay, that means my weights are not getting, at some point of time, it has become infinite. That means there is something wrong. So I can go back and change maybe my learning rate. Maybe I can change my activation function. So there are actually a lot of things. It's not easy to understand and learn neural networks. It's a kind of 6 months course basically. Okay? But I think you have got decent idea how these things are done in the industry. Okay, right now we are just dealing with a small amount of data, but in industry you have huge amount of data. So you have to go to some, you have to use some services from the Azure or maybe AWS. You go there, you choose your machines and you train your data there. They also come with their services so that some of your tasks are further simplified. Okay.
Okay, and then how do we select the model? Like, I mean, so do we need to have like knowledge on that, like for
Yes,
selecting the
yes.
model?
Yeah. Usually what happens once your data is cleaned, see, when you are dealing with any machine learning problem, the most challenging thing is to clean your data and to bring your data into such a state which can be fed to your code, basically. Okay, so you have to clean your data. You may have to merge couple of columns. You may have to drop some columns. You may have some lot of categories in the column. So you may need to club those columns into a single one. So did lot of data engineering you have to do. That is called feature engineering. You have to do, so 60-70% time goes into that. Once your data is ready, right? Training the model is usually very easy. What you can do is, as I said, you can just select one model. Usually, linear regression is an old algorithm, it will not work. So most of the time you use decision tree or random forest or XGBoost, these type of algorithms. But once your data is ready, it's just a matter of few lines, right? You just fit your data and you train your model, and you get your accuracy. If your accuracy is not good enough, you may switch to some other model. So that is usually hit and trial kind of thing. But most of the time, as an experienced person, you actually know which algorithm is going to work for a given problem. That comes with the experience. For regression problems, there is one algorithm which works the most. For your classification problems, there is some other algorithm which works the best most of the time. Okay. All right. I think we have covered a lot, but we haven't proceeded much in our course. Quick 5 minutes break, guys. Or you want to continue?
Break.
Break. Chalo, theek hai. We'll see you guys at 9:35. Okay.
Yeah.
All right. Let's take a break. All right. Are you guys back?
Yes.
Yes.
Yes. I hope you are enjoying the session, guys. You're not getting bored or something.
It's a good start. Definitely a good start.
All right. Chalo, ठीक है. So let's discuss why all of a sudden we have been talking about this generative AI. What are the reasons why this has become possible, right? So couple of reasons. For example, there is massive amount of data which is being produced. So you have seen, right, in the last 10 years or 15 years, the amount of data which is getting produced, right? Everything has been automated. Right? We have a lot of applications, lot of, I mean, even in the government companies, we can see the things are getting automated and a lot of digital data is getting generated. So there is a vast amount of data which is getting generated every minute, every day, right? And now we also have something called availability of scalable compute capacity. Earlier, this capacity was not available, or let's say there is some guy who is, doing some research, and if he has to test some algorithm or he has to train some model, he had no means basically, right? Or he had limited means. He has to go to the university or college where they were having some resources or servers, then only he can do. But now these days, because of the availability of these cloud platforms, we can spin up the machines, we can get these resources very quickly in just few hours or few minutes basically. Right? The servers, the GPUs, the TPUs which are available, you can make use of them very easily by getting into these platforms, your Azure, AWS, GCP, right? So the amount of data which is being generated or available, the ease with which I can get the compute capacity. And third is the machine learning innovation. These algorithms also got evolved over the time. For example, this transformers architecture, which is the backbone, or which is one of the state of the art architecture, which is being produced by Google, that is one of the major breakthrough in this history, which helped these systems to evolve and get better very quickly over the last few years. So these are the three main reasons why we see the generative AI. Lot of things, we are developing so many applications in this, and we are seeing a lot of large language models being released every other day or week. So now we have seen what is AI, what is machine learning, what is deep learning, and now let's see what is generative AI. So when we have something, some models which can basically generate new content or new ideas. So those contents can be text, that content can be images or videos. Then we start calling those AI systems as generative AI systems because they are generating something new. They can generate a face which they have not seen in the past, but they have learned the features of the human being. They have a nose, they have eyes, they have eyebrows, but with that data or with just a single prompt, they can generate some image or create content which they have not seen in the past. Okay, so that's the most peculiar thing about these LLMs. Okay, we will see what are LLMs, how they are trained, everything we are going to see. This also we discussed, right? Traditionally, when we train our model, for example, we trained the housing price model, right? So can I use that model for other tasks? No, I cannot do text generation or summarization or question answering or anything else. I cannot even use that model to calculate the price of houses in some different location, in some different country altogether, right? So these ML models are basically very limited to the task on which they are trained, and they are not at all good for NLP problems. So these are NLP problems: text generation, summarization, information extraction. They are dealing with the language. So these LLMs, which are very much in the fashion these days, they have the good thing is that they are basically good at lot of tasks at a single time. Okay, so you can use ChatGPT for the text generation, summarization, information extraction, everything, all the tasks in one go. So that's why these foundation models or LLMs are very popular these days, and everyone is trying to exploit their power to build the applications. Okay, I hope that makes sense. A single foundation model, a single GPT model or the OpenAI's model can serve various tasks. It can do text generation and things like that. All right, then there is something called inference. What is inference? Whenever we give some input to a model and it generates the output, that input is basically called prompt. The output is called completion, and this entire process of providing the prompt and getting the completion is called inference. Okay, so this is just the terminology which is being used in this industry. So you should be aware what is inference. Once I train my model, and when I start using it, I give it some prompt and it does the completion. It gives me the response. Let's say I say translate the below sentence from English to German. I will give my sentence. It will give me output as a German sentence. So this is called inference. I inference that model basically. Okay, as simple as that. Now let's talk about LLMs. Right? So what are LLMs? LLM are again, they are also machine learning models, but they are trained on large corpus of the text data for weeks and months. So their training is not as easy and as fast as we have done couple of few minutes back. We just imported one CSV file and our model got trained. Here we are talking about some data which is in petabytes. Such huge amount of data is passed to these machine learning models, and they get trained on that particular data for weeks and months, for 2 months, 3 months, and 6 months. That longer these trainings are there, and they also consume a lot of power, lot of electricity power is being required for them to run, for their cooling or to maintain the servers and things like that. Now, what these machine learning models does, they predict the next token, then repeat the process until the completion. So in our previous models, we were passing some numbers, some features, but in these models, we passed basically token. So there is a word, there is a term called token. So token can be referred as roughly as a word. Okay, so we have basically some tokenizers. If I pass this particular English sentence to my large language model for training, the first thing it will do is it does not understand English, right? My model does not know what is predict, what is next, and what is token. So the first thing it will do is it will convert that word into a token. Okay, so basically it will convert from English to some mathematical representation or some ID basically. Okay, so the entire sentence is converted into some IDs, and those IDs are passed to the my model. Okay, rest the concept is same. It's just the architecture is different. These models are based on transformers architecture, but the training and reducing the loss, all these things remains the same. We are passing some numbers, so and it get trains on those numbers. So this is not a magic wand or some machine which can understand the English. It still deals with the some numbers or some maths basically. Some people call these LLMs as huge statistical calculators or machines. So what is a large language model? They are big models which are being trained by a large amount of data which these companies scrape from internet or from some Wikipedia or some sources. And then what their aim is, the training aim is to train the model in such a way that they are able to predict the next token. The words are converted to tokens, and they are trained in such a way that if you give a sentence as an input, that model is trained in such a way it can predict the most likely word after the last word. Okay, so this we will see in just a moment. And then they are built using transformer architecture, as I said. So transformer architecture was the architecture which was released by some researchers in the Google in the year 2017. There is a very famous research paper called Attention is All You Need. So that release of the paper or the release of this architecture revolutionized the entire space. So all these models which you see today are based on transformer architecture only. Just like we had machine learning algorithms and then we changed to the neural networks. Within the neural networks also we had something called convolutional neural networks, recurrent neural networks, and we have GRUs, we had LSTM. So these are different architectures. In 2017, we came up with an architecture which was very efficient than all the previous architectures. And why it was efficient? Because it was able to understand the large or context of the data. Okay. And what it does, the transformer outputs the probability distributions over the vocabulary given the input sequence. So what it has is, it has basically a dictionary of all the tokens. I mean, you can think it as an Oxford dictionary, which has all the words. Okay. So when I give an input, when I input one sentence, what it will do is it will scan the entire dictionary of the word, and it will be able to predict what should come next in the sentence from that dictionary. So it will give the probability score of each and every word which is there in his vocabulary or dictionary. It will say after the word over, these should come, it has a probability of 0.6, and all other words maybe 0.6, किसी का 0.2, the sum should be equal to 1. It should not increase 1, right? That's the basic probability rule. Okay, so if things are not clear, maybe in the next few slides you will get more clear understanding of what I am talking about. So it consumes a lot of compute power. What is the parameters? The memory of the LLM. So when we say there is a model of 70 billion parameters, so those parameters are weights, and that is acting as a memory of my large language models. Okay, just like we say this hard disk is of 1 TB, then that is the space or the amount of data it can carry. Similarly, the number of parameter is the memory of the large language models. More the memory or more the parameters, more it will be its memory. Memory in the sense it will be able to understand more and more complex patterns in the data. Okay. So this is that transformer architecture which I have been talking about. This was released by Google researchers in 2017. And I will not go into the depth of this because we are not here to create such models or train these models. Today we just use these models which have already been trained and which are there in the market. We want to use them, not create them. But if you're interested, you can go through the research paper. I will give you the link. Let me show you right away. Attention is all you need. There is this website where all the research papers are there. So if you go to this website and if you search attention is all you need, you will get this research paper. If I click on the PDF, this you can see Ashish Vaswani from the Google Brain. So these are Google researchers, basically from Google Research. So they worked on this architecture and they have released this paper. Okay, if you have some basic understanding, this is the same diagram. If you have some basic understanding of NLP, then you can give it a try to understand. But for this course, that's fine. Even if you don't understand, just understand at a high level what it is. Okay, you can download and just try to go through. There is a lot of mathematics. So I will explain you at a high level what happens. There it has two parts. The left hand part is called encoder. The right hand part is called decoder in this architecture. And once we give our text data as an input, the very first thing which happens is input embeddings. So this is like tokenization. My words are converted into some tokens or some IDs, which my machine can understand. It will create those embeddings of those words. This is called positional encoding, which will help me to retain the sequence of my input words. In the language, sequence is very important. I cannot jumble my words. In my housing problem, if I jumble my data, if I put 100th row at the first place and the first row at the 100th place, it does not make sense. It does not impact. right? Even I can shuffle the columns also. But here, when we talk about language, the order of the words is very important. Otherwise, meaning will change. So in order to retain the order of these words, we do something called as positional encoding, which give, some reference. Okay, output is at 0, serial number off is at 1, 2, 3, or some kind of encoding, basically. Positional reference is given. Then my words are passed into this multi-head attention layers. They are again basically layers. In this, what happens? This encoder basically try to understand the hidden meaning of the sentence. There is something called attention. Then even the name of the paper is attention is all you need. So what these models are built in such a way, the architecture is such a way that they give more weightage to the words which are more important in a word. And they keep on assigning those weights or weightage to those words. Once those words enter into this part, once they come out, this model actually knows the meaning or the context of that particular sentence, the hidden meaning. क्यों क्या कहना चाह रहा है user और sentence में क्या लिखा हुआ है basically. And it is passed to the decoder. The work of the decoder is to find the next probable word. Okay, so what it will do is there is something called softmax layer. So this layer will give me the probability of the possible tokens. If in my dictionary, as I talked about, in my dictionary there are, suppose let's say there are 1,000 words only. So this softmax layer will tell me the probability of those 1,000 words in a score like 0.1, other maybe 0.02. It will tell the probability of them being the next word as a probability. And we will choose the word which is having the highest probability, and that word will again be passed into my as a next token, and the system will again try to find out the next token to that. Okay, I will just explain you here. So let's say I have the sentence, why did the chicken cross the? If this is my input sentence, if I pass it to my model, what it will try to do is it will try which word basically fits the best, which has the highest probability to come after this word to follow this sequence. Okay, so what it has done, first of all, it will split my entire sentence into different tokens, and each token may not be one exact word. It can be like, just a second. It can be like the one word is split into two different tokens. Okay, this one word can be split into two different tokens. It depends on the tokenizer. It may be like chick is one token, en is another token. Okay, so anyway, this sentence is split into different tokens, and those are passed into my neural network. And then it will say the probability of the word road is maximum out of its dictionary to come to the next to this word. And then this road will again be passed into my network again to see what should come after the road now. Having said this entire and this full sentence is why did the chicken cross the road? Now it is able to find out, okay, there should be a question mark. So it will find out, okay, question mark is the most probable token to become to the next. So this works like this one. Okay. So this is how this architecture and LLM are trained and they work. Let's dig a bit more on how a LLM selects the next token. The model uses a softmax function to output a probability distribution for each word in the vocabulary. Okay, so let's say in the vocabulary, if I have 1,000 words, then for each word it will give me some score. Okay, the probability of road being the most likely word after this sentence is 0.2, river is 0.1, house is 0.05, banana is 0.02. And then what will happen, my system will select, okay, this is having the highest probability, so let's produce it as an output. सबको आया समझ में या नहीं आया? Is anyone who does not understand Hindi? Please let me know.
Yes, Surinder, this is Ashok. I
Mm-hmm.
don't, I mean, I can understand some bit of Hindi,
Mm-hmm. Okay.
but not completely.
Okay. That's fine.
So, in this case, how did it come up with the probability that road should get a high 0.20 but not river? How did that?
So that comes with the experience with the training. So we have trained the model with lot of data. So now
Mhm.
it can, tell us which word is the most likely.
Got
Okay.
it.
So let's say I have lot of articles. Okay.
Mm.
Lot of newspaper articles which I fed to my model. Those articles are like today, the Prime Minister of India, Mr. Narendra Modi, went to US. He met the president and blah blah blah. So it has lot of news about Narendra Modi. So now my system knows Narendra Modi is the Prime Minister. So if I give an input, Mr. Narendra Modi is, then it will be from its training. It can tell me, okay, the next verbal word is Prime Minister of India. Okay, so it all depends on the training basically. जैसे हम just like we teach newborn baby once he is like 1 year old or so, he listens so many things from all the people around him
Yeah.
that at some point of time he gets so trained that he himself starts speaking,
Mm.
isn't it?
Yeah.
Yeah, same like that in case of these LLMs, we train it with so much of data that at some point of time it is able to understand the language. Okay, so then there are some configurations. Okay, so where is that? Okay, training is here actually. Okay, so maybe I will cover this training first and then we will go to the configurations. So how LLMs are trained? There is something called pre-training, right? So this is basically unsupervised. As someone was asking, right, how these models are trained. This first training, which is called pre-training, is an unsupervised way where what we do initial phase where the models learn from large corpus of text data, learn general language patterns and structures, just like we understand the language like English, right? These are the consonants, these are the vowels, these are nouns, these are pronouns. So when we feed lot of data, it understand the pattern, how this English is being written, which words, okay, after each word it has to put a full stop. Okay, this means example or things like that. Learn general language patterns and structures, data, massive data sets, books, articles, and websites. They take those that data from these online, some e-books, articles, websites. These companies scrape lot of data. And what task is there for the models? Predicting the word in a sequence given its context. Okay, so this is basically unsupervised learning. They are asked to predict the word in a sentence given its context. Context means the full sentence is given and their aim is to predict the next token, to find out the next token. Captures a wide range of language knowledge, creates versatile base models, requires substantial computation resources, may contain biases from a training data. If our training data is not good enough, if it is biased in the sense it's being more inclined towards some bias side. I mean, if my articles criticizes PM Narendra Modi, then my model will learn, okay, PM Modi is not a good prime minister, which should not be the case. Right? My data should not be biased to some particular way. It should not favor maybe males or on the basis of color or something. So I have to be very particular when I'm choosing the data for my training. So as I said, petabytes of data is scraped, but you will be surprised to know only out of those petabytes, just 2 to 3% data is appropriate enough or chosen for the actual training. So that's why this training is not an easy task and it's not being, which is usually done by every other company, right? There are just few players in the market who are able to get access to this data and they have resources to train these models. Not every other company is training their own models. Okay, so they takes lot of huge power, and that's why these companies are actually acquiring nuclear power plants to power their models or their data centers where this training is being done. Okay, and it's being burning their pockets. It's take a lot of dollars to train these models. It's not easy. So this is called pre-training, And you can see there are two things which are very important. One is the text corpus, okay, the amount of data, and the model size, the number of parameters we have. This text corpus should be of good quality, unbiased data that will determine the quality of my model, and also the model size, the number of parameters. If we talked about neural networks, we have neurons which are acting as a memory. So if I say 70 billion parameter model is there, that means it has 70 billion weights or parameters to carry or understand or store the patterns in the language or the data. Okay, so based on these, my pre-training is done and the output is my language model. Second part of training is called basically fine tuning. Now, after pre-training, my model basically knows the language patterns and things like that. It is able to understand, but it is not good enough to perform some task. In order to perform some task, what I want, I need to do some fine tuning. I have to train it further in a supervised manner. If I want my model to be good enough in question answering, then I will be giving a question and answer. That means I'm labeling my data. I'm also providing answer to my questions, and I feed that particular thing to my models. Okay, I give question, it will generate some answer, and then it will say, okay, my actual answer is this, not this one. So sometimes there is a human in the loop who will say whether the output is right or wrong. He will thumbs up or thumbs down. So it will take that feedback and it keep on getting fine tuned. At some point of time, it is able to understand how it has to behave in case of question answering. Similarly, if my task is translation, I say translate this sentence into French or German language. What it will do is I will give it a lot of examples. This is my input sentence. This is my translated sentence. This is my input sentence. I will give one data set. And this my model will learn from that. Okay, it will come to know, okay, if my instructions and questions are like that, this is how I need to behave. This is called fine tuning and this is supervised. Similarly for NER, and this is entity recognition. What is N? Okay. NER is entity recognition. You have to, let's say I say grab or pull all the name of the persons or the places from a given article. Named entity recognition. Okay. So it depends on the task. So I make it aligned to my task basically in fine tuning. Let's read this one. Second phase where the pre-trained model is adapted to a specific task. We specialize the model for a particular application, data, smaller data, task specific data. It's just like a student has learned till 12th class and now he's, entering into an engineering college to learn a specific branch, let's say computer science engineering. So he will learn more about computer science now. He has general knowledge on science, biology, or maybe some maths and some other subjects till date, but he is not specialized to answer anything from the computer engineering field. So now we are graduating him in a particular field. Now after this training, he will be graduated from the college and he should be able to answer you anything on the computer science engineering. I hope that analogy will help you. So smaller task specific data set, medical records, supervised learning with the labeled data, enhances model performance on a specific task, reduces need for large data sets, can overfit if not properly managed, requires high quality labeled data. I hope that helped.
So is fine tuning more expensive
No.
than
This is not expensive because this is being done on a very smaller set of data.
okay?
Even we can fine tune a model. You
Mhm.
just need to go to your any platform like Azure or AWS. You just prepare your question set. Maybe you can also prepare some 10 question answer set and you give it to your model. It will use that platform and get fine tuned on that.
So pre-tuning is more expensive than where we dump everything sort of.
Exactly. Yes.
Okay.
This
So
is very, very expensive.
pre-training takes a lot of effort, right?
Hmm.
Once you have the pre-trained model, then you can do the downstream task, which is fine-tuning, relatively easier.
Correct. It takes 12 years from first to 12th class, right? This cool.
Makes sense. Okay. So, got it. And I was gonna ask one more thing. So when you see all these open source models like Llama, you would consider them as pre-trained for us general purpose, and then we fine-tune after forking them based on our needs?
No, they are already fine-tuned basically.
Okay, they're
Mm.
also fine-tuned. So how,
Mm.
so, but then like there's so many open source models, right? Llama,
Mm.
Quen, and quantized, non-quantized, all that stuff.
Mhm, mhm.
So, but how are you deciding then which one do you go with? They're all being pre-trained and they're all being fine-tuned.
Mhm.
So then what makes you say, okay, I'm gonna use this one versus the other one?
Correct, correct. So usually in industry, when we are dealing with some enterprise customers or clients, we usually go with OpenAI or Gemini or these models. We don't go with the
Mm,
open source models.
mm,
Okay, because there is a huge difference in their performance as well,
mm,
right? And if you use the open source models, you also need to deploy it somewhere,
mm,
right? You have to download the model and you have to
mm,
deploy into your environment. You have to
mm.
also need to
Do the inferencing, yeah.
you need to get the hardware also to run that model.
Mm,
So usually 99% of the time what these services companies are doing is they are using OpenAI models or Gemini models, and they are using these platforms, and they are just deploying those models in their platform, and they are using their APIs to inference them. Okay,
yeah.
rest is being taken care by themselves. You just need to select your model and you need to just click on the deploy button.
Yeah,
Within
yeah.
within few seconds, it will get deployed in your account. You have your own Azure account, right, or your client account. Log into that account, select the model, deploy it. You need not to select what hardware or what machine. They will do it because they are charging you on the basis of number of tokens. Rest, they are taking care of it.
Got it. Yeah. So one more thing. What's the
Mhm.
difference between foundation model and LLM? So there is a foundation model and then
Mhm.
there's the LLM, right?
Yeah, I mean, foundation models are basically the pre-trained models basically, and then you fine-tune them to become some specific models which are useful in some particular task. So
Okay.
at the very first time when you train a model, it knows all the things, but it is not able to perform the task, right? In order to align it with your, some specific task, you need to fine-tune it.
Got it. Okay.
Yeah.
So then, so unless you fine tune a model, it is a foundation model.
Yes. Yes.
And then once you have fine tuned, then it is a LLM.
Hmm.
Okay. And one more question. You said these are all based on transformer
Hmm.
architecture. What about MOE, mixture of experts?
I mean, I haven't heard about MOE. I think you put this question also,
Yeah,
in the.
we can talk next time. You can
Maybe I will
go.
explore what it is.
Perfect.
Okay, let's proceed. So these are different LLM providers. This slide may be a bit older, but I think there is still the leaders: OpenAI, Google, Anthropic, Mistral, Meta, Grok, and Hugging Face. Okay, out of these, they are basically model creators. For example, OpenAI has models like GPT-4o, 4o, O3, Mini, and all those. They have Gemini 2.0, 2.5, Anthropic, Mistral. So they create the models. Meta, Hugging Face, and Grok are basically platform which host the models. Okay, usually open source models. So we will be using Grok in our entire course because this is almost free of cost. Okay, and Hugging Face is basically a platform where you will get a lot of things like, you get the models. You can also host your models with some price. You can get a lot of data sets. If you want to download some data set for training your models, you can get the data sets. So this Hugging Face platform is mostly used by researchers a lot to do their research because they get a lot of models to download, lot of data sets to train their models and things like that. Okay, so usually these models are divided into three parts. One is proprietary models, which are like OpenAI closed source models. OpenAI's models like 3.5, 4, 4.0. This list is quite old. Now we have 4.5 also, we have 4.1, we have O3, all these models. Gemini is also, I think the latest model is 2.5. Anthropic has Haiku, Claude Sonnet, Opus. So these are closed source models. They are proprietary to these companies. You cannot use it yourself. You have to get the licenses, or you have to create the keys in order to use them. Okay, keys are also required for them, but their weights are not exposed. You cannot download them, and you cannot do anything with that. You don't know basically what architecture they have used, where it is being deployed, and things like that. Open source models are the models which you can download. You can also run them on your laptop as well. If the models are small enough, as you were saying, right, there is a model called Qwen. If you are using Qwen for 4 billion parameter model, you can download and run it on your local machine as well. Okay. Your laptop hardware should be, if you have 16 GB RAM, I think you can run smaller models like 3 GB, 5 GB, up to 5 GB. So these are open source models. These Llama models are very efficient and very famous. These models are usually hosted on the Grok platform. I will show you all these things, and you can inference or call these models. There are other providers, as we talked about, Hugging Face and Grok. These are inference points. Hugging Face inference endpoints host a vast repository of open source models. Grok is an platform, and they claim that it's an basically inference engine. They claim that once they host these models on their platform, the inference rate is response rate is very fast. One of the fastest engines in the world. Okay, if you want to go through, there is something called the leaderboard. As you were just asking, right, how to know which model to use. This is another way based on your task. If you want to see, let me go to this website. Okay, so if you go there, you will see all the different, this updated on 6th of June. So there are some benchmarks, right? For example, benchmarks are, some benchmarks, or some data set on which you can rate the different models. Right? So different companies are releasing their own models. So how would you know which model is performing how much? So that's why you have some data sets. For example, you have some 100 problems on the reasoning. Then you test these models when they are released. They are being tested on these problems, and you define the score. Okay, out of 100 reasoning problems, OpenAI model has been able to score 86.4. It was able to solve 86 problems correctly. So that's why you have given that Gemini 2.5 Pro as 86. In the reasoning, Grok 3, I think this is from that Elon Musk. So this Grok 3 is scoring 84. So they are being scored on different benchmarks. Okay. So if you have task which is more on the reasoning, you would like to go with the Gemini 2.5. If you have some task which is more on the school maths or some mathematical things, you can go with your Grok 3 or OpenAI models. So these are being different scores. I hope you are getting what I'm trying to say. These are the fastest models, tokens per second, Llama 3.3. So on the various benchmarks, you will get these scores. Okay. You can also compare them. If you want to compare two specific models, just select those models here, and then you will get the difference of these. What is the context size? What is the cutoff date? The cost of input output tokens. For the input token is $0.1. For the each output token, it's like 0.4. This cost is in millions basically. For 1 million tokens, the output tokens, the cost is 0.4. This is $3 or $15. Okay. So you can compare these models on the various aspects.
We can
All
drop a
right.
link on the
Yeah.
chat. Bro.
Sorry.
Drop
Okay.
the link.
Chat.
In the chat.
Okay. Okay. Yeah. There are various actually such, leaderboards on, you will also find on Hugging Face. So this is that. Different providers. Now, what is prompt engineering? What happens is your inference basically depends on how good your prompt is. So the crafting prompt to guide the behavior and response of LLMs. Okay. What is the goal? To elicit accurate and contextually appropriate outputs. Your output basically depends on your input. Whatever prompt you are writing to the model, that will basically decide what should be your output. So it is very important in this field to craft your prompts very carefully. Okay. There are some models where if you don't give any example, you just give an instruction. For example, your prompt is translate the following English sentence to French. Good morning, bonjour. It will give you output. But in order to align, let's say you have some specific needs and you want your answer to be in some specific manner. So what you can do is you can basically give some example, some question answering example even in your prompt also, so that your LLM will come to know, okay, this is how you are expecting the output to be produced. So this is called few shot learning. If you are giving one example, it is called one shot learning. If you don't give example, it's called zero shot. If you are giving two, it's a two shot. Multiple means few shot learning. Okay. So crafting the prompt is very important. You should give instructions carefully in such a way to align your response. This we will see throughout the course, right? How to write the prompts. Now there is one important aspect that LLM is not same as the applications. For example, ChatGPT. ChatGPT is, I mean, I know now this is very evident, but in the earlier days, 1 or 2 years back, people were confused whether they mistakenly were saying ChatGPT is a model. So it's not a model, it's an application basically. Right? The model is running behind this ChatGPT application. Okay. So ChatGPT, which we use on the daily basis, is an application, and your large language model, which can be GPT-4 or GPT 3.5, that is running behind the scene. Whatever is prompt which we write on the ChatGPT is it's being passed to my LLM, and the output is received from the LLM. Response is received. But apart from that, I have a lot of things in my ChatGPT interface, right? I can, all my past conversations are stored somewhere in the database, right? I have option to log in and log out, right? I have an option to start the new thread. So these features are not coming from LLM, they are coming from your application. Okay, LLM is just one service in your entire architecture. I hope it's clear. For example, if we talk about OpenAI, GPT-4, GPT 3.5, GPT-4, these are different models available through APIs as well. ChatGPT is a web application. So when I give instruction to my ChatGPT, its API is called, some prompt is given, response is received, and then there are a lot other things which this application is doing. Okay, they are showing interfaces, some text box, some previous chats. There are some settings. You can go and change some settings and things like that. Similarly, for Anthropic, we have these models and Cloud Chat as an application. So there is a difference between these two, you should know. LLM versus application, this is again same thing, which I have explained in more. For example, this ChatGPT application is having features like conversation memory. It has a storage for the past conversation. It may have some authentication service. Everything is being plugged into the my ChatGPT web application. And LLM is just one service. It pass the prompt, it get the completion. This LLM can be any of these models. Now there is a model called FLAN T5. And this is one of the older model, I think in 2020 or 21, before ChatGPT or these GPT models came into the world. FLAN T5 was also one of the famous models. Okay, so why we're talking about this an old model which is not being used today? The reason being, it will help us to understand some features, some low-level features which you don't see in the ChatGPT. In ChatGPT, you just give your instruction and you get the output, but you don't know what is going under the hood, behind the scene. So this will help you to understand a little bit on how things are being done. So FLAN T5 is text-to-text transformer model, a transformer-based model developed by Google. Okay, and the most good thing was that this was a multitasking model. It was a model which was able to understand the instructions. We just need to give the instructions and it will be able to do different variety of tasks. Otherwise, earlier what was happening was, if I fine tune my model on one task, it will forget the other task to do. If I train it heavily on my second task, it will forget to do it. It will forget how to do my first task. But this was one of the first model which was able to do multitask based on the instruction. So I need to give the instruction like, please answer the following question. What is boiling point of the nitrogen? Chain of thoughts, all these things. So I need to give, if I want to translate a sentence, just need to give translate the below English sentence into the French or German. Okay. So this model is there on the your Hugging Face, and Hugging Face also has a library called Transformer Library. We can use this Transformer Library to inference this model. Okay, this we have already talked about. This is a small lab. How much time it is? Let's quickly finish if we are able to finish. So what I will do is I will open Google Colab. Again, you have some question what it is. This is an online or an environment which is running on Google platform, where I can run my notebooks. So earlier I was running my notebook in the VS Code, isn't it? And it was running on my local machine. But what Google has done is they have given us a platform, collab.research.google. I can go there and I can run my IPYNB files. Python files can be run on this platform as well. So instead of writing commands one by one, I will open my okay, I'm already in the same folder. Where is my file? Just a second. Parallelly, I will go through my Hugging Face. This is the Hugging Face. And am I logged in? Yes, I am logged in. So as I was saying, it has a lot. There are around 18 lakh models which are there on this platform. Okay, and you can filter them by different tasks. If you want to get the models on text generation, it will filter those models. If you want on the basis of number of parameters, 6 billion parameter model you want some smaller model, you want some larger model. Basically, you can filter these models as per your needs based on libraries, PyTorch, Transformers library, all these things, apps and different things. Dataset, you will be able to find a lot of data sets. If you are creating your own model, you can download some data set and use it. Some documentation, some pricing. If you want to deploy your model, you can basically deploy that model as well on their hardware. Okay, so what we are mainly interested in is plan T5. So if I say plan T5, I can see these many models, right? So I will do what? I will use plan T5 base model. So once I do that, you see the same set of diagram, right? It talks about the model and all those things. Okay, so what we want to do is we want to use this model. So I will go back to my notebook. So there are some details about this model you can just go through. First of all, we need to install our Transformers library. Okay, so this is a library, just like we have pandas, we have NumPy, other libraries, we have Transformers library from Hugging Face in order to inference the models which are hosted on it. Okay, and this Transformers does not mean we are actually installing Transformers architecture. Okay, it has nothing to do with that architecture. Okay, it's just that they have also named their library with this name. Okay, so I have installed that library. Okay, and now what I need to do is I need to log in. So they have this authentication mechanism. So just go to your user. You can log in with your Google account, and then you need to go to settings. In the settings, I need to go to access tokens. What is the password? Is it done? Create new token. Batch 3. Let's say this is my token name. Do I need to give some permissions? Right. Create token. So this token has been generated. So this token I will pass so that I get authenticated with this Hugging Face repository. Now I am logged in. Next is I will use tokenizer and T5 for conditional. These are libraries which I need to classes which I need to import. Okay. Let me install them. And here you can see Google/Flan T5 large. From where it is coming? It's coming from this name. So I'm using this large one. If I click on that, if I click here, you will get the name. You just click on this squares, Flan T5 large, copy and paste it here. Okay, so we are using T5 tokenizer and we are using this pre-trained model. I will get a tokenizer object and I will get a model object. I'm showing you this because you will come to know what is going on behind the scene. I hope you guys are following. सब सो गए लगता है.
No, we are following the.
Okay. So I will explain the code by the time it downloads. So what we do is, this is my sentence. Okay, this is my input sentence. Translate the sentence into German. This is my instruction. My name is Surendra. This is my input text. So what I will do is I will use the tokenizer which I just defined and I will give this input text, and this is return tensor pt PyTorch. Okay. There are just two ways. One is PyTorch and other is what? There is one more actually. PyTorch and I just forgot the name. Okay. And I'm trying to fetch the input IDs. As I said, when you pass your sentence to a tokenizer, it will generate some tokens, some IDs from its dictionary. Okay. For example, this translate will get some number like 23. This will get some 1005. Okay. So these words will get changed into some tokens. So let's see what are those tokens. So this sentence has been changed to some tokens, like this is 30,355. D has been changed to 15 and things like that. Okay, because my model does not understand English, right? So I have to change into some mathematical format. So this is how my sentence got converted into some tensor or some vector, basically vector or some mathematical representation. Okay, this you won't see on the ChatGPT, right? But all these things happen behind the scenes. Now I have got this input IDs. These input IDs will be passed to my model, right? To generate the output. So if I click that, I will get some output. I have got the output. What I will get in the output? Output also I will get some tokens, isn't it? So I need to use tokenizer.decode this output, and then there is a parameter called skip special tokens. I will make it true. So this output will be also in this fashion. This I am again decoding into the language German. So this is Ich bin Surendra. Okay. So what it has done, it has translated my input sentence, my name is Surendra, to Ich bin Surendra. Anyone of you knows German? No. Okay. Okay, so this is how this model has worked. Okay, so I have shown you it in a greater detail so that you understand all these things. So this is the summary. We installed we loaded, we prepared input, generated, translate. So you can go through these instructions and it will be helpful. All right, I think we have concluded for the day. Any questions, guys, before we close for today? I think it was helpful. It was a bit heavy, but just go through the recording once and you will be, yeah, tell me.
Yeah, so this example is from the Hugging Face, is it? Or what you just...
Correct. This model is there on the Hugging Face. I just showed you, right?
Okay.
Yeah. So I inferenced that model from my machine.
Okay. So I think you mentioned about using Visual Studio and this Collab, right? So when do you use these tools exactly?
Yeah,
So
see, Visual Studio is generally used when you are building some application, right? You have different folders, you have source, you have prompts, right? Today also, when I work for my company for a project, I use Visual Studio Code so that I can build my entire project. This Google Colab is something where you try to do something and you don't want to set up all the virtual environments and things like that. You just go and create your own file, you run some commands. All these commands are running not on your local machine, rather they are running on the Google platform.
Okay, right. That's
okay. So it is using that engine, not my local. Okay. Usually whatever codes I have written, right? So if you want to run these codes, you can simply go and import this file in the Google Colab, and then you will be able to run the cells one by one. If you go to VS Code, you may mess up. I mean, if you are not habitual, but we will learn that also. How to build projects, enterprise level projects. We will here we are just dealing with a single file, right? Nothing else, just one file. There we will create 20, 30, 40 files to create an entire full project, full-fledged. All right. Anything else, guys? I hope this was informational.
It was.
Yeah, I mean.
Surendra, what is the advantage you see with Visual Studio compared to Eclipse?
See, Eclipse is more like from the Java. I mean, when I used to work in the Java, I used Eclipse, right? So VS Code is one of the latest IDE which is being used across the industry. So I haven't compared actually. I just following the trend. Eclipse, I'm not sure how compatible it is with Python. So this Visual Studio Code
We can do Python
Is it
in Eclipse
free
also.
or
Plugins
paid?
are there.
Is it free or paid?
This is free actually. You can use this free. Okay. You can just go to your download Microsoft VS Code. So Microsoft is having good hold on this OpenAI. They have collaboration with the OpenAI, right? They host their models, and so it's better to use VS Code, which has good integration with all these things. You have plugins, you can directly deploy your models, a lot of things are there basically. Okay.
Okay, I think we should wrap up now.
Yeah. I mean, we are already over 30 minutes. All right, guys. Thank you so much for your patience, and I hope I was able to justice the time you invested, guys. We'll see you next week.
Thank you.
Thanks
When
everyone. Bye
we
bye.
will
Yeah.
get the recording?
You will get in by evening.
Okay, on the WhatsApp page. No?
Yeah. I will WhatsApp the location. Thanks everyone. Thanks. Bye bye.
Thank you.
Thank you.